Now we'll look at another kind of dimensioning and tolerancing, and that is the measure of the surface texture. In other words, surface finish or roughness. And you might think, oh well, a part could just be smooth, but no, it can't. Remember what we know about drafting and design, that there are no perfect parts, period. And to think about this, you might want to think about the idea of fractals. This mathematician, Mandelbrot, in 1967, he published an article, and the title of the article was, "How Long is the Coast of Britain?" And it turns out there is no one answer. If you're way up above the Earth in a satellite, it's going to look smoother than if you're a surveyor down walking on the ground and seeing all the bumps and inlets. And if you use a long stick to measure the coastline, you'll get a short number. If you use a short stick to measure the coastline, you'll get a much longer number. And you can keep on measuring finer and finer right down to the grains of sand, and you'll get an even longer number. So the point is, there is roughness in any part, no matter how smooth it appears. The question is, how much roughness is there? And this matters to you as a designer because you want your parts to fit together. If you look closely at surfaces of parts, you can see grains of metal if it's a metal part, and you can see that even in a machined or a ground part, there is roughness. So here's a drawing, and let's say you want these parts to be smooth, and you trust your machinist, so you just write these notes on the drawing: grind smooth. This is not good. This is an opinion, and what you think is smooth and what your machinist thinks is smooth might be two entirely different things. So this is no good. We have to give them numbers. And remember, we need numbers that are measurable. We need dimensions. This chart, you'll see this chart over and over again all over the place. This is the surface texture chart out of the ASME standard, which relates to roughness, which relates to surface texture. And this chart gives you a sense of what degree of surface finish you might expect with what kind of process. Now, if you look at this chart, first of all, you notice at the top, okay, looks like the plane numbers are in micrometers. Those are millionths of a meter. Here's how you write micrometer. That's a millionth of a meter. And then in parentheses, those numbers are micro inches, and they are written with that Greek letter mu for micro inches, and a micro inch is a millionth of an inch. So if you have a surface finish of 250 micro inches, that is 250 millionths of an inch, or a quarter of a thousandth of an inch. So now you can look at these numbers up here. Here is 250 micro inches, and you can see that lands you right in the middle of sawing and planing. But you notice if you want to do something like, let's say, milling on a milling machine, you're going to get a finer finish, maybe a 125 or a 63. And even finer and finer finishes, like if you do polishing or lapping, you are up here in maybe 8 millionths of an inch. We find even surface finish call-outs in structural steel. This is an example from the AISC Steel Construction Manual, just for your interest. So what are we measuring when we measure this? If you get a microscope and you look up close at a cross-section of the surface you're talking about, it won't be smooth. It can't possibly be, because there are no perfect parts. It will be bumpy. And when we give our surface finish in millionths of an inch, we are talking about from the highest peak to the lowest valley. If you measured this height and it were 125 millionths of an inch, or 0.125 thousandths of an inch, you would be telling them from the highest peak to the lowest valley, you want it to be no more than that. Now you can buy these fairly inexpensive surface comparators where the comparator shows you examples of what the various finishes look like. And you can look at them and you can think, oh, with your eye, you can think, oh, I see, the fine finish is shiny and the rough finish is rough looking. This is helpful, and I recommend if you get yourself one of these comparators, you use your fingernail carefully to scratch the surface of the metal rather than relying on your eye, because reflections can be deceptive. So as this illustration points out, this is from a metrology book, you might have a part that's very, very rough and actually get what appears to be the smoothest reflection. So what you need is a tool to measure the surface roughness. And we don't do that as drafters and designers, of course, but in the quality assurance shop, they will have measurement tools. This tool happens to be from NIST back in Washington, D.C. And according to ASME, the measurement is based on an electronic feedback from a stylus. So I'm just showing you what that looks like, just FYI. You can buy hand measurement tools. Here's one that will give you a digital readout. And if you decide to go into the quality assurance field of study, you will spend more time in math. And here is what that surface roughness is actually saying. It's actually a statistical average. We don't need to know that. I just put this in here, FYI, for your information.